Well, hello there. Thanks so much for stopping by. Now that you're here, let's have a few moments together as we are comparing bits and pieces. Let's do a review together. So what I'm going to encourage you to do is I'm going to show you a problem, math problem. I want you to press pause on the video and I want you to work out the problem. And then you can press play and I'll kind of talk you through it a little bit and we'll see how we did. You're looking for your misconceptions, misunderstandings, and I want you to fill those puppies in. All right, here we go. Number one, write each of the following as a fraction. So let's do that. Let's do first fractions. So I've got 4 problems up here. Let's write all 4 as fractions. So why don't you press pause, write them all as fractions, and press play and see how you did. You didn't press pause, just press pause. There you go. All right, so fractions, it's 20 out of 50, so it's going to be 20 out of 50. And I could reduce that down, or I could leave that just like that, 20 out of 50. This actually reduces all the way down to 2/5. 10 correct out of 15 problems, so that's going to be 10 out of 15. And I can reduce that down because they both are divisible by 5, divisible by 5. So that equals 2/3. So I got 2/3 correct. Woohoo! 1 out of 5 games won. That's 1 out of 5. I'm going to leave that alone. And then the bottom one says 21 out of 31 ice cream flavors. So that's 21 out of 31. All right, so now you're going to go ahead and we're going to do decimals. So decimals, why don't you press pause, work out the decimals, and come back and let's see how we did. And pause. All right, the rest of us, we're going to keep going here. So decimals. If I remember right, if we can get these things to tens or hundreds, that's good. So if I can take 20/50ths and get it to 100, then I can see the decimal pretty easy. Or 10. Oh, I'm going to take 2/5 and turn it into 4/10. See that? Times 2 times 2. So 4/10 as a decimal is just like I'm saying it. 4/10. Boom, nice. Okay, 2/3. Now, okay, 2/3, I'm actually gonna, that's one that I've memorized, and that's one you should have memorized. We should memorize that 1/3 is, I'm gonna go red, 1/3 is one of those that 1 divided by 3 equals 0.3 repetent. It's 0.3333333. So if I have another one of those, if I've got another one of these guys where it's 0.333333333, both of these together, 2/3. So 2/3 as a decimal is 0.066666666666. Yeah, a little bit creepy when I do it that way. All right, let's keep going. Don't stop. So 1/5. Ooh, if I can get this to a 10. So times 2 times 2. So these are nice equivalent fractions. That's 2/10. So I want to get the decimal, so I just read it 2/10. So I write down the number 2, and I just make sure that is in the tenths place. 2/10. If this was if I made it 20/100ths, then I would write down 20, and I would make sure the last digit is in the hundredths place. So there, that's what 20/100ths look like, which actually is 2/10. Yeah. Okay, 21 out of 31 ice cream flavors. Ooh, this one's a wild one. 3, 4, 2, 3. I'm trying to find some ways. Can I shrink this down at all, or can I get it to 100? Can I get it to 10? All right, 21 over 31. Okay, can I get 31 into 10? No. 100? No. 1,000? I really can't do anything, and I don't have a calculator, and you don't get a calculator. So this one, actually, we're going to hold on this one. I'm not going to go any further in this one because this needs your calculator. And on my calculator, I would do 21 divided by 31 to get whatever decimal it is. But you and I don't get to have calculators for this one. What's next? Percents. Let's go ahead and press pause, get the percents, and go. All right, I know you did all the percents because you paused it, worked them out, and now it's our turn to check them. So 4/10 is actually 40% because it is 4/10 is equal to 40/100ths. And that's where percents are coming from. And also, I just moved my decimal also 2 places because it's out of 10. Let's try this one. 66. Oh, this is a wild one. So if I move my decimal 2 places, I got to keep in mind my 6 does keep going. So this is actually 66.6 repetent percent. Holy Moses, that's kind of funky. And then we got our other one here, which is 0.2, so which is 2/10, or 20 hundredths, which is 20%. That's a bad 20. Whoa, goodness, out of control here. 20%. And we can see that right here, moving at 2 places. All right, and that last one, I'm just going to leave that alone. That one's going to give me a headache. All right, the ratio of females, okay, so ratio of females, which is 14, to, and that's like my ratio, to total students, which is 25. So notice the order. Females, which is going to be our first number, 2, which is your ratio, total students is 25. So the order that I write my sentence in is the order I write my number sentence in. And that's going to help us. So why don't you go ahead and try these ones out. I've got these 2 questions. Press pause, you try, and then I'll try. All right, you tried. Let's see. What fraction, which is actually a ratio, of the class is male? Okay, what fraction of the class is male? So that means fraction is going to tell me it's a part to whole. So I'm going to do male over, it's the whole class. Okay, so it's male to the whole class. What do I know? I know that there are 14 females in a class of 25. So my class is 25, but I need to know the males, not the females. So I'm going to do, if there are 25 total, minus the 14 females, I should get the males. So 4 minus 5 is 1. Oh, that means there should be 11. So that should be 11 males to 25 students. Okay. All right, there's my fraction. Check! What percent of the class is female? Okay, so that brings me back to, there are the females to the class. Oh, that's my original thing up here. So that's 14 over 25. Ooh, I'm liking that 25. I just got to get to 100 and I'll see it. So times 4. So 14 times 4 will give me an equivalent fraction. 4 times 4 is 16. 4 times 1 is 4, plus 1 is 5. So it's 56. And I can do this a couple different ways. Percents is out of 100, so this is telling me that it is 56%. Or I can say the decimal, 56 hundredths, tenths hundredths, so it's right there. And then I move my decimal 2 places to get my percent. What percent of the class is female? It's 56%. And because I know that, I can also find the percent of the males through subtraction. But let's not do that. Let's move on. Number 3, circle the fraction. Ooh, okay. Decimal or percent that is not equivalent. Now, just for a strategy, I'm going to make sure I see the word not, because I don't want to answer this wrong. So it's not equivalent to others. Explain why it's not equivalent. So I am going to explain it using math. So let's see, 25%. All right, let me see. 25% is actually 25 out of 100. So maybe if I turn that to that one, let's see, that's 4 tenths hundredths. That's 4 hundredths. This is the fraction 1 over 25. Okay, you know what? I'm going to make this one, because all the denominators are out of 100, so I'm going to get these built up to be out of 100, so that's 100, and that's 4 100. So it's looking like this one's the same and this one's the same. And before I move on, I'm going to look up and see what the question's saying. Circle the fraction that is not equivalent. Hold the boat. Back up the train. This is not true. I want to circle the one that is not. So that would be my way to answer this question. This is not, and I have my proof there. Arrange the decimals from least to greatest. Ooh, how exciting. I love this. I'm going to create like a number line a little bit, and I'm going to get 0. Now 0 doesn't have to be in the middle, folks. It just needs to be somewhere. So this side is my negatives, and this side is my positives. And let's start going here. Negative 18 is like way negative. Positive 18 is like, oh, where's my manners? Why don't you stop and you try this, okay? Press pause, you work this out, and then come back and let's see how we did. All right, we're back. So 18 is way positive. Now this guy right here, this is like 18, this one right here, sorry, 18 tenths, hundredths, thousandths. This is 18 thousandths. So if I got 18 jelly beans out of 1,000 jelly beans, I did not get that much. So this is a really small negative number. And if I think absolute value, distance from zero, that's like really close to zero, but on the negative side. So really close to zero. 18th, this is my last positive one. So this is going here. 18 tenths, 18 hundredths, which is small. So it's over here somewhere. Oh, negative 18 hundredths. So this is like on the other side. Okay. Negative 1/8 is, it's closer to zero than negative 18, but so that's going to be like right here. And now negative 19 tenths. 19 tenths. Let's look at that. 19 tenths. So the 9 needs to be in the tenths place. So this equals negative 1.9. And 1.9 is more negative. It's further from zero. So it's going to be right there. All right. That's it. These two are the only two that I would say are a little bit tricky, but you got to place them right. And you had to convert this guy so you could see it better. 19 tenths is negative 1.9. And it's further from zero, so I got to put that on that side. Cool beans. Decide whether the fractions are equivalent or not equivalent. Let's see, 8 tenths, 5/4, 3 halves. I'm going to see, maybe I can either get these two up to 8. I can get this down to 4 and that up to 4. Let's just, I don't care. Pick one. You do one. I just got to get them so I can see their values. I'm going to go ahead and make this smaller. So 8 tenths. No, I'm going to keep that one. 3 halves. I'm going to make it bigger. So times 4 times 4. So that would be 8. 4, 5, 7, 8, 9, 11. This is 12 eighths. All right, that's already looking like not equivalent. 5/4 equals something. So times 2 times 2. So that's 10 eighths. Oh, okay. Decide whether the fractions are equivalent. So I decide that these two are equivalent. And it doesn't say to circle or anything, but somehow I'm going to represent that. There's my proof. 8 tenths equals 8 tenths. Ta-da! Oh, maybe I'll even write this. 8 tenths is equal to 5/4. Smiley face. Crazy hair, small ears. Yes. Ooh. Anson drinks a lot of Mountain Dew. That's so not good for his stomach and stuff. I hope he's not a kid drinking too much caffeine, because that's not good. Anyway, so he noticed that during 1 hour, okay, so I'm going to underline that so I don't lose track of it. I'm not going to scratch it out. I'm going to underline it because that seems like something I should know. Okay, he noticed that during 1 hour, he drank 9 cans of Mountain Dew, okay, so that's important. I'm going to mention that. And 5 of them were code red. Okay, so, all right, got my stuff. Press pause, you work it out, and come on back. Check me out. All right, welcome back. All right, you didn't leave, did you? Okay, press pause, work these out, and then come back. All right, now you're back. Good. I'm so glad you came back. That's so nice. Mountain Dew. What is the ratio? Okay, so it's a ratio which is going to look like a fraction. So I'm going to build it now. Start my fraction of code red Mountain Dew. Okay, code red Mountain Dew. So that's going to be code red. 2, and that's my fraction or my 2 dots, the other cans of Mountain Dew. So that's kind of what's left over. So others. Okay, so let's figure out. So he had how many code reds? He had 5 code reds, and then we want the others. So a student might accidentally put 9 down, but 9 represents all of them. We don't want the 9, we want the others, the other cans of Mountain Dew. So if it's 9 total, and he drank 5 of them, that would be a total of 4. So it's a 5-to-4 or 5-to-4 ratio of code red to the other cans. Hey, that tells us he drinks more code red than the other ones. What's the unit rate? Okay, for every 1 code red he drank. Okay, so the unit rate, that's going to be per total. So we're at a 5 to 9. Okay, so he drinks 5 code reds for every 9 cans of Mountain Dew. So it's 5 to 9. Let's see, 5 to 9. All right, I'm going to take a look at this. So unit rate is telling me that it's for every 1. Okay, so I need to get down to 1. So right now I see that he drinks 5 code reds for every 9. But when I look ahead at the question, the next question is talking about minutes and hours and stuff like that. So I'm actually going to be looking for a different unit rate. So sorry it isn't very clear that B is being very clear, but really B for B, it's asking for the unit rate. It's how many code reds per hour. And when I look at this, he drinks 5 code reds per 1 hour. So 5 code reds per hour is where he's at, so per hour. And knowing that information, I can use that to find the next one. Suppose he continues drinking Mountain Dews. That's awesome. At this rate, for the next 6 hours, how many code reds will he drink at that time? So if he drinks 5 code reds in 1 hour, how many will he drink in 6 hours? Now some of you, whoa, that's really bad handwriting. Now some of you will not want to write it this way, but I'm going to ask you to please write it this way. Because really this whole chapter is about equivalent ratios and equivalent fractions. So 1 hour times 6 got me to 6. So 5 times 6 is 30. So this is my proof that it's 30 code reds in 1 hour. Yikes, that's a lot of Mountain Dew. How many fifths are in -8? How many fifths are in -8? Well, in just one piece of it, so that's like one of the negative ones, there's a whole bunch of them. Fifths, there are like 5 fifths in there. So I want 8 of those. I want 8 of those things. So if there's 8 of those groups and one of them has 5 fifths, that means there should be like 40. Yeah, there should be 40 fifths. And we're talking negative, so there it is. Yeah, -40 fifths equals -8. Okay, yeah. Let's try it with, oh, there's 2 questions here. How many fifths are in 4 fifths? Okay, well, if I have a whole, 1, 2, 3, 4, and I'm talking about 4 of them, 1, 2, 3, 4, there are 4 of them. Therefore, there are 4 fifths in 4 fifths. Nicely done. That's a nice one. That's a good one. Oh, rate each fraction as a decimal. Holy moly, this one just keeps going. Rate each fraction as a decimal. Once you press pause and you try it out. So 1/8 is one of those decimals I'd encourage you to memorize. 125, it's one of those. There's ways to get to it, but it's hard because 8 doesn't actually go to 10 or 100, but 1 divided by 8 is 0.125 or 125 thousandths. Yeah, that's hard to get, and you're not going to have a calculator, so you're not going to be able to do that. So 4/8 is my next one, which, look at this. If I reduce it, it's 2 fourths. Oh, which is actually 1/2. Oh, so this one is 0.5. Nice. 5/8. Oh, 5/8 is actually going to be these two together. It's a 4/8 and a 1/8. So I can do 0.125 plus 0.5, right? So isn't that 0.625? Yeah, there's my answer. 5/8 is 0.625. Not because I used a calculator, not because I've memorized what 5/8 is. It's because I know what 1/8 is, because I memorized it, and I found 4/8. 1/3 is one of those funky ones. That's the 0.03 repetance. 2/10 is 2/10 is 2/10. That's funny. And 4/50ths, I am going to make out of 100. Times 2, so it's 8. It's 8 hundredths. So tenths hundredths. Yep, there you go. That's the answer. Number 8. Are we done? Oh, yummy. There's more. Write each decimal as a fraction. Oh, this is so nice because I just need to say it. 1. Okay, that's my whole number. So 1 and 9. And then I can read the place value. Tenths hundredths. Ta-da! For this one, I'm going to read the 2, so 2 tenths, hundredths, thousandths. Oh, that can be reduced to 1/500. Yes. 3, that's my whole number, and 6, I'm going to say the number, and then the place value tenths. Oh, but that can be reduced. 6/10 is like 3/5. Nice. Oh, look at this guy. 12, that's my whole number. And I'm going to read that. So 12 and 3/10 hundredths. 12 and 3/100ths. That it? That's it! Yay! We did it! Dun, 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 dun. I'm going to accelerate. Put myself in a panda suit and run around the zoo and see if anybody pets me or feeds me. Oh, I'd love to eat a little bundle of panda food. Wait, what do pandas eat? Aren't they like leaves? So I guess it's like salad. So I'm going to put on a panda suit and run around a zoo until somebody feeds me their salad.